Hi there, in this video we're going to talk about the chain rule, but first I wanted to just review a few of the things that we did in class, which we were able to do the general power rule. So if you remember, the general power rule for derivatives essentially says if your f of x is x to some power, then the derivative is n times x to the n minus 1. So you bring the power down and you decrease it by 1. And if you have a constant, right, if g of x is something like a x to the n, then the derivative of g is a times, and you still bring the derivative down, the power down, so it's n x to the n minus 1. And so those get multiplied. So for example, if you had something like 6 square root of x, and this was your f of x, then f prime of x will be, well, first let's rewrite it. So f of x will be 6x to the 1/2. Right, if that was a cube root, this would be 1/3. If that was a fifth root, this would be 1/5. 6x to the 1/2. So the derivative of that is, according to this, it will be the constant stays 6 times, bring the 1/2, bring the power down, so it's 1/2 x to the n minus 1. So 1/2 minus 1, 6 times 1/2 is 3, and then you have x to the negative 1/2. Negative exponent really means it belongs on the bottom, so you have 1 over x to the 1/2. So the final answer of our derivative will be 3 over the square root of x. So that is the general power rule. The other thing that we talked about was the product rule. So the product rule is when you have the product of two functions. So if you want to find the derivative of the product of f times g, then this told us that it's the derivative of f, so the derivative of the first times the second, plus the first left alone, f times the derivative of the second. And so this is the product rule. So for example, if I had some function h of x equals to, say, x to the 6 times x to the 5th plus 1, of course we could just multiply it in through and get the derivative, but let's practice the product rule. So the product rule says the derivative of the first, so 6x to the 5th, times the second left alone, plus the first left alone, x to the 6th, right? You can kind of think of this as your f and this is your g. So then this is f prime g, and then this is f, and now we're going to do g prime. The derivative of x to the 5th is 5x to the 4th. And so this is your g prime. And then you simplify it. So my h prime of x then would be 6x to the 10th plus 6x to the 5th. And then what does this become? Plus 5. When you multiply the exponent, the same basis, you add exponents, so 5x to the 10th. Combine like terms, so I'm going to get 6 plus 5 is 11, so 11x to the 10th plus 6x to the 5th. Which notice that if you multiply this out, that's what you should have gotten as well. So that's the product rule, and then the other thing that we did is the quotient. And the quotient rule is if you take the derivative of, if you have f of x over g of x. Now depending on what the variable is, that's how the notation is going to change, right? If this were functions of t, so this would be the same as if I wanted to do d dt, for example, of f of t over g of t. So whatever your function is defined in respect to, then that's how you take the derivative. So the quotient rule essentially says if you have the derivative of a quotient is going to be the bottom, so g times f prime. So this is where I did in class the low d high, so derivative of the top, minus, for the quotient rule is minus, so low d high minus high d low over the bottom square. So an example of this would be, let's say k of x is 3x plus 4 over the square root of x. Now, do we have to use the quotient rule for this one? No, but let's just practice it. All right, so the quotient rule says to do the bottom times the derivative of the top. So our k prime of x is going to be the bottom, the square root of x, times the derivative. So I'm going to write an extra step here indicating I'm going to take the derivative of that. So the bottom times the derivative of the top, like low d high, minus the top f times the derivative of the bottom. So 3x plus 4 is the top, times the derivative of the bottom. The bottom is the square root of x. Since I'm going to take the derivative, I'm going to write that as x to the 1/2. And I'm going to take the derivative of that all over the bottom function square. So the bottom function is the square root of x, and I'm going to square this. So k prime of x becomes the square root of x times the derivative of 3x plus 4. Derivative of 3x is 3. Derivative of 4 is 0, so it's just 3. Minus 3x plus 4 times, now I need to do the derivative of x to the 1/2, which is 1/2 x to the minus 1/2. We did it on the previous problem as well. And the square root of x quantity square is just x. And now we simplify. So when I simplify this, I'm going to have k prime of x is equal to 3 root x minus, bring the 1/2 x to the minus 1/2 in. So I'm going to have 3/2 x times x to the minus 1/2. When you multiply same bases, you add exponents, right? So you have a 1 here. So x to the 1 times x to the negative 1/2, you're going to add exponents. So it's really 1 minus 1/2. So it's x to the 1/2 plus 4 times 1/2 x to the minus 1/2. But because we have a negative, the negative from our quotient rule, we have to distribute that in as well. So it's going to be minus 4 times 1/2 is 2 x to the negative 1/2 divided by x. And now we work on simplifying. So I'm going to have k prime of x is equal to 3 square root of x minus, notice that x to the 1/2 is also a square root, so 3/2 square root of x minus 2 over x to the 1/2. A negative exponent means it really is 1 over, so all over x. So I'm going to think of this x as x over 1. So instead of saying all over x, I'm going to say, instead of dividing by x over 1, we're going to multiply by the reciprocal, 1 over x. And that avoids us having that complex fraction. So now these are like terms. So 3 over 1 minus 3/2, we have to get a common denominator. Common denominator is 2, so multiply this by 2 and that by 2. And so it's really 6 over 2 minus 3 over 2. So I get 6 over 2 root x minus 3 over 2 root x. So 6 minus 3 is 3. So I get 3 over 2 square root of x minus 2 over the square root of x times 1 over x. And now I can work on distributing this 1 over x in. So I'm going to have 3/2 root x over x minus 2 over root x times x. When you multiply that in, and again, use your rules of exponents to simplify this. So this is x to the 1/2, and remember when you're dividing the same basis, you subtract exponents. So it's really 1/2 minus 1, but that's going to give us a negative exponent. So instead, think of doing x to the 1, subtracting from the bottom. 1 minus 1/2 is going to be x to the 1/2 on the bottom, minus 2 over, here they're both on the bottom, so I just do x to the 1/2 times x. So we add the exponents. When you multiply the same basis, you add exponents. When you subtract the same base, when you divide the same basis, you subtract the exponents. So here I get x to the 3/2, and this is our derivative. Depending on what my math lab wants, you may have to do a little bit more rewriting, simplifying that exponent by 2. This is the square root of x cubed. So it just kind of depends how your answer is, how they want it in my math lab. So that kind of reviews the general power rule, product rule, and the quotient rule. So the next thing that I wanted to talk about is the chain rule. And the chain rule is when you have essentially a composition of functions. Notice that's the other operation. So far we've done when you add functions, when you subtract functions, we've done the derivatives. When you multiply functions, you have the product rule. When you divide functions, you have the quotient rule. So what about when you have a composition of functions? So this is for composition of functions. So what is a composition of function? Remember, this is when we do like f of g of x, things like that. So we want to look at an example that I'm going to do is, let's look at what if f of x is, let's say, 2x squared plus 1, and then this is being squared. So what we would probably want to do without the chain rule, since we don't know what the chain rule is yet, is we can rewrite f of x by foiling it, using the distributed property to expand this out. So f of x then becomes, what's this, 4x to the 4th plus 2x squared plus another 2x squared, so plus 4x squared plus 1. So this is f of x. So f prime, now that I've rewritten it, I take the derivative, will be 4, bring the power down, so it'll be 16x cubed, subtract 1 from the exponent, plus, bring the power down, 8x, and the derivative of 1 is 0. So my derivative is just 16x cubed plus 8x. So what is the chain rule? What the chain rule says is that when you have a composition of functions, the derivative of the composition of functions is the derivative of the most outside function, so f prime. G stays untouched, and then you do times the derivative of g prime of x. So this is the chain rule. So for our same function, f of x is, what was it, 2x squared plus 1, and then the whole thing was squared. Then here, the outside function is the squaring, right? So notice that I've done, essentially one of the ways you can think of it is let g of x be the inside, the 2x squared plus 1, and f of x is x squared. So if you compose these two, f of g of x, right, this means for every x you see in f, substitute g of x. So f of g of x becomes g of x squared. But what is g of x? G of x is 2x squared plus 1. And so that's how we get that composition. So essentially then, we've already defined it here. So the outside function is the square, and the inside function is the 2x squared plus 1. So when I do my f prime, I'm going to take the derivative of the outside function first. Right? This is the outside function. So what's the derivative of this? The derivative is 2x. So the derivative of this is going to be 2 times, and then you bring it to the 1, right? You subtract 1. Notice that it says the derivative of the outside function, the inside is left alone. So I'm going to leave g as it is. So I'm going to leave it as 2x squared plus 1. But then it says times the derivative of g prime. So I'm going to say times g prime of x. Well, the g is 2x squared plus 1. So my derivative here is going to be the 2 from the outside function, the inside left alone, times the derivative of the inside function. The inside function is 2x squared plus 1, so the derivative of that is 4x. 2 times 2 is 4, and then it just becomes x. The derivative of 1 is 0. So finally, my derivative is 2 times 2x squared plus 1 times 4x. Simplifying that, multiply the 2 and the 4x to get 8x times 2x squared plus 1. And now you can multiply the 8x in. So I get 16x cubed plus 8x, which is the same thing that we had gotten by multiplying it out. So you might be thinking, well, if I can just multiply it out, why do I need this confusing chain rule? Well, what if h of x instead was, say, the cube root of 2x squared plus 1? Right? Now I can't multiply anything out. I can't expand anything. Same thing, or if I had a different function, k of x is 2x squared plus 1 to the 10th. I would not want to multiply that out. So that's where the chain rule comes in handy.